Okay. So let's start, now that we've done a little bit of algebra review, let's start moving into what this unit is about. And basically, it's about square roots and cube roots, as well as new types of exponents that you haven't seen before. There are actually fraction exponents, like 49 to the 1/2. Okay, there are negative exponents, and we're going to talk about how to do those. And we're going to do some algebra with those exponents as well. But let's just start off. Some of this is review, some of this is new. It's a perfect square. Okay, why?
Because you can times a number by itself to get.
Okay, so how would you write a definition of perfect square then? According to what you just said.
The
It's number.
product of a number times.
Yes. So it's a number. That can be written as another number times itself. And that would be like you said, 4, because 2 times 2, 100, because 10 times 10 is 1/9 a perfect square. Can you write 1/9 as some number times itself? 1 over.
Wait, no, 3.
1/3. 1/9 is a perfect square. Remember, we did fraction perfect squares last year. And we did a few decimal perfect squares. Okay. And when we take the square root of a number, square root of a number is a number when multiplied by itself. Gives you the number under the square root. So like the square root of 25, what number times itself gives you 25? 5. Square root of 16/49, what number times itself gives you 16/49? 4/7, right? Okay. Perfect cube. Well, you told me what a perfect square is. What do you think a perfect cube is?
3 multiplications.
Okay, so can you give me an example of a perfect cube? And why? How can you find a perfect cube? Pick a number. Okay, multiply it by itself and by itself again. That's a perfect cube. Right? 27 is a perfect cube because it's 3 times itself times itself. So a number that can be written as another number times itself times itself again. So like we just said, 27 is a perfect cube because it can be written as 3 times itself times itself. Can you give me an example of a negative number that's a perfect cube? Negative 27? Different than 27. You're right, negative 27 because negative 3 times negative 3 times negative 3. Negative 125. Excellent. Why? Because it's negative 5 times negative 5 times negative 5. Fractions can be perfect cubes, so can decimals. Okay? And when we try to find a number that times itself gives you a number, we are taking the cube root of that number. So when you take the cube root of a number, is a number when multiplied by itself and by itself again equals the number under the cube root. I'll show you what a cube root looks like in a second. We could keep going. Okay? We could have perfect fourths, as in a number that can be written as another number times itself, times itself, times itself. Or we can take the fourth root of a number, and on and on and on. Okay? When we take the root of a number, okay, that is represented by what's called a radical. So you guys have been doing square roots for quite a while now. Why that did that? Go back. Yeah, it's over here now. And I got a big line across my. Okay. So a radical represents the root of a number. If it's a square root, that's a type of radical. So examples, square root, 64. That's the radical. When we evaluate the radical, we get 8. We are finding the number times itself, which equals the number under the square root. A cube root looks like this. It's got the square root symbol, but to show it as a cube root, we write a little 3 outside. So the cube root of 125 What number times itself gives us 125? That's 5. Okay. Technically, when you write the square root, and we're going to need to know this later on, although you guys never wrote it, okay? It's just like we never write the exponent 1, do we? Like if it was 7 to the 1, we don't leave it like that. We write it as 7, right? When we do a square root, technically, we should be writing it like that. But you don't have to. So whenever, if there's no number here, you always assume square root, which is what you guys have been doing for quite a few years. And like I said, we can keep going up and up and up and up and up. 4th root, 5th root, 6th root, 7th root, okay, and on forever. So radicals look like this. Where n is the root or index, it's often called as well. This, sort of the check mark with the vertical, with the horizontal bar, this is called the radical sign. And whatever's underneath the radical, we're going to deal with numbers now, but it doesn't necessarily have to be numbers. It's called the radicand. All this stuff that I just did, okay? You don't have to worry about writing definitions. The only reason I talk about these is so that we can use the right terminology when we talk about this thing. Because sometimes I will ask a question like this, and I will ask somebody, can you read that for me? And sometimes it's a bit of a struggle to read. Because some will go like 3 and then a root, 3 square root 8, which is not correct. It's 3rd root 8. Okay, so you want to make sure that you read it correctly. Okay, so that's what they look like. Let's actually find some values. Now, you can do all these questions without a calculator. Like you could do these questions with the bigger numbers, but we're not going to. We're not going to worry about that. Okay? If we encounter something like that, we're going to use a calculator to help us. But these ones, smaller ones, you guys should know what to do without a calculator. What's the square root of 81? 9. How do I write the cube root of 64? How do I write it before I find the answer, before I evaluate it? Well, I'll jump in at once. Hard to hear. Level 3. Okay, then the radical sign.
And then.
Right. 3rd root 64. And what is it equal? What times itself gives you 64. You can usually take an educated guess and then check it. 2? No, too small. Because 2 times 2 times 2 is 8. 3? No, that gives us 27. 4. 4 times 4 is 16 times 4 is 64. Now we're getting big. This is where we want to this is where a calculator comes in handy. So we want to find the square root of 1,200. Hopefully all of you are able to do that on your calculator. Just make sure you are. Okay, because you may be asked to do some large numbers as part of solving a problem. Did we get an answer? What did we get? 36. Does anybody need a hand? Okay. This next one, the third root, or the cubed root of 1,728, this might be a little bit more challenging. Figure out how to do on your calculator. On mine, I've got a button that I have to get to by shifting that looks like this. So what you want to do is you want to press 3 first because you're doing third root or cube root. Then press this button. Then enter 728. So for mine, I'm going to go 3 for third root, second, and then mine is there. 1,728, and I should get 12. Okay. Does anybody need a hand with that one? Usually more people do. Let's make sure that we've got a handle on that. Perfect squares between 10 and 50. 49, 16. So maybe let's start with the little one, 16. Any others? 25. Any others? 36, and then we also said 49. That's good. Perfect cubes between 0 and 50. Not from 0 to 50, between 0 and 50. 25, that's a perfect square, not a perfect cube. 8, 1, 8, 27. Now we're getting too big after that. So those are the ones. Okay.
If we were able to, would we use 0 as a perfect cube?
Yes.
0 times 0 is times 0.
Yes. Yeah, right. These ones. I'm thinking the first two, okay, maybe you need a calculator, definitely for B. But for the next two, I can probably do without. Easy set. Easy. Just for that, I'm going to get you to do one of C or B. You can do it, believe me. With your brain. But in the meantime, what's the square root of 625? 25. Okay. This one, yeah, I calculated. Sure. She says with great confidence. Yes, 17, like that. Okay, Sam. Sorry, just one second. Okay, Sam.
Wait, it is
I'm waiting.
G over 8.
Nice. See? Because remember, how can you do that? Well, the square root of 9 over 64 is the same as the square root of 9 over the square root of 64. So do each one separately and then write your final answer as a fraction. And then you can do this one similar. Same as the cube root of 27 over the cube root of 8. Which will give you what? 3 over 2. I don't know what's with you guys. I hear that all the time. When cube root 27, so many students say 9.
Because I'm going to see if I remember.
I got you.
I will really.
You can't promise that.
Yeah, I don't get happy for 3 years.
Okay, well, how do you get what? Okay, you see this. Cube root of 27 is what? What times itself gives you 27. Right. What times itself gives you 8.
Oh, okay, yeah.
Yeah, good.
Okay, so what is Oh, okay.
There you go. See? Okay. Okay. So let's look at a couple of problems. Before that, this is actually, not part of grade 10. We do it more in grade 11, but I'm still going to introduce it now. Yeah, you're in. What do you think the square root of x to the 6th is? So remember what a square root is. What times itself gives you x to the 6th? Isn't it going to be an exponent? No? Yes, no? What times itself gives you x to the 6th? Nice. Because you got to think of their exponent laws. X to the 3rd times x to the 3rd equals x to the 3 plus 3, which equals x to the 6th. Good. What would be the cube root of y to the 12th? What times itself gives you y to the 12th? That's the square root. Because if you do y to the 6th times y to the 6th times y to the 6th, your exponent's too big. You want to change your answer? 4. Because y to the 4th times y to the 4th times y to the 4th is y to the 4 plus 4 plus 4, which is y to the 12. Yeah. Yes, you can with cube roots. And you could do this with square roots too. Okay. Here's a couple of problems. A square has an area of 196 square centimeters. What's the perimeter? She says no. What do I need to know to find the perimeter of a square? I need to know its side, because all 4 sides are the same, right? Well, I know the area. How could I find the side from the area? Take the square root of 196. And when you do that, you're going to get 14 centimeters. Okay, that's the length of one side. Now remember, we're finding perimeter. Sometimes students get mixed up between perimeter of a square and area of a square. Yes. So triangle is 56. Good. We can do problems with volume and surface area. Now, we didn't do volume last year. We did surface area cube. But to find the volume of a cube, we just remember in a cube, all the edges are the same. Okay, so in a cube, all the edges are the same. So we call one L. This is L. This is L. And so the volume would be L times L times L. Surface area we did last year. We did L times L, and because there's 6 squares that make up a cube, we times it by 6. Okay? So you're told that the volume is 4,913 cubic inches. So that means the volume is the edge length cubed but I know the volume is 4,913. I need to find L, don't I, in order to use the surface area formula. Well, you can kind of think what we've been doing in algebra. How do you get rid of a cube? What's the sort of opposite of it? Not divide. No. No, not square. What's that? What's the opposite of squaring? What's the opposite of squaring if you go backwards? Like if I want to get rid of a square, what do? Square root. No. If I want to get rid of it, hey, listen. If I want to get rid of a cube, what do?
Square cube. No.
Square cube?
Square root.
How do you get rid of a cube by doing square root? You get rid of a square by square root. You get rid of a cube by cube roots. So to find L, I do the cube root of 4,913. Remember, cubes and cube roots are related. Squares and square roots are related. Don't mix them up. They don't mix with each other well. Like cats and dogs. Well, some cats and dogs do. What? So what's the length? What's the cube root of 4,913? 17. We're halfway done. Oh, sorry, this is inches. Because remember, we have to find the length. Now we know that this is 17. So now we use the surface area formula because we now know that L is 17. So we have to use the volume formula to find L and then use that L to get the surface area. Remember correct order of operations? What would be this answer?
1,734.
Do I have a second person that can confirm it? Thank you.
Correct. How do you?
17 squared, 17 times 17. And then you have to times it by 6. Like this? No.
Square.
Thank you.
How does my calculator say alpha?
What does your calculator say? What?
Alpha?
Alpha? Which is, I don't know. You probably press some button. Probably press some button that you should be. 45, what?
Alpha.
We use alpha to represent an unknown angle in math.
Like a lone angle.
Like, I don't know if you guys have done this, have you seen this in science? Hello? Have you guys seen this symbol in science? Yeah, and everybody's no, but Dana's yeah. Dana. It's in their own little way. You're very good. You're right. So what does it stand for? Oh, I see what you said. Cosine. No, we do cosine with this. You're right. We do sine with it. We do tangent with it. We're going to be learning trig later this year. Okay. But this is actually, anybody know the Greek letters? Well, alpha is a Greek letter. It's the first letter in the Greek alphabet. It looks like that. That's alpha. The next letter in the Greek alphabet is beta.
Gamma.
Yes. This is another letter in the Greek alphabet.
Alpha, beta, gamma.
Delta. Epsilon.
We only know about the first three.
I think I'm stuck too. I know other ones, but I can't remember the order. What's that? This is actually called theta. Theta. How about the one at the end? That looks like this. Omega. Omega. Okay,